So with that, I want to say a big CSC welcome to Orville. Can we get a little applause to start? Come on up, Orville, and take it away.
All right. Hello, everybody. Let me get set up over here, and thanks for inviting me, and thanks for coming to listen to my talk about Rust, which I don't know a whole lot about. So if you have any in-depth questions, hold them until the end, like till I'm out of the building. No, ask any questions, but I might not be able to give you the answers. And thanks, Kat, for setting everything up here. So yeah, I spent a year learning Rust to do a 5-minute PHP job. That is not actually hyperbole. It took me that long. So why did I go into that? So I'll give you some info about me to give you some context as to why I even thought this would be a good idea. You'll understand what kind of crazy person does this. But at the end of the talk, I'm hoping that you guys figure out you can be this crazy too. Because I think Rust is a underrated language. I know GitHub has their survey, and every year it's like, oh, it's the most loved language, but I don't see a lot of people actually using it in enterprise, at least not in the fields that I'm in. And I would love to see that happen more, because if you want really robust code that runs really quickly, is memory safe, it's a great option. So let's learn a little about me. So I'm Orville. That's the black guy to the left, to my right. And this is my wife, and I've got a whole gaggle of kids. So the oldest one, Ashton, Parker, Quentin, Zoe, Nina, and she's not like a month anymore. She's a year now, but that is Micah. Now she's toddling and walking around, which is pretty fun. So that's my family. I've got a few kids, from 15 to 1. And one of the things that one of the jobs I've had is a student, because I like to be someone who is always learning, and a researcher. So that's what I did before I was a developer. And of course, a husband and a dad, because I've got these guys. And after that, I also became a technician, so like a lab technician. So I tried to do a PhD, failed out of the program. And then I was like, you know what? I actually like science. I like being in the lab more than I like being like studying things. So lab technician is a great job. And then I started having a lot of kids, and I was like, well, that doesn't exactly pay for the family lifestyle that I have with a whole bunch of kids. So I was like, God, you got me into this situation. I would really like you to get me out of it. And he opened up an opportunity where I could become a web developer. It was just like a 3-month contract. Started working on that. 3-week contract. 3 weeks became a month, became 6 months. 6 months into it, they're like, we'd like to hire you. And I'm like, yes, this is awesome. So they hired me, and the rest, as they say, is history. So fast forward a couple years later, I'm now like people would like to say full stack engineer. I like to say 2/3 engineer. I do not like the back end. I hate databases. But yeah, it's true. I hate them. But I do like working on the front end. Love the front end. I also like doing DevOps type work, just automating things that can be automated, never touching them again. So as a part of getting into development, I decided I'm going to get a VPS. That's what they used to call cloud servers before they called them the cloud. And I bought a Linode, and I set up Linux on it. And then I put my first website up, and that was going to be like my portfolio, because I'm not a designer. I can't like show pretty pictures and pretty designs. So I was like, this is the website. It's got the HTML. It's got the nicely crafted CSS. It's got the JavaScript, which is there's a sprinkling of that on there. And I was like, this is going to be great. People can go look at the code, right-click, view source, be like, this is what he can do. And then it kind of snowballed. So it started off with just one server, and then I started adding more and more things. So then I was like, I want a blog. And I was like, I do not want to use something like WordPress, which I had run, and Drupal, because I'd heard about SQL injection and stuff, and I started being more cautious about security. So I was like, static site is for me. I got Jekyll up and running. It came with a PHP script that had a contact form. And I was like, all right, how do I set this up? And I looked into it, and I was like, nope, that's too much work. So you could never contact me from my blog. I just put a link at the bottom. I was like, contact me on Twitter or not. It's up to you. And people actually did. So that was cool. So after that, the Linodes run Linux. And I got kind of disgruntled with the state of server-side Linux. Ubuntu had moved to something called system D. I didn't like some choices they made there, so I was like, I'm going to look for something else. So I got into BSD as my server-side operating system, and that's where I discovered containers. And this wasn't Docker, though. FreeBSD has a system that they have for containers. It's called jails, and I really like how it's set up. You've got like the same thing like Docker. You've got one kernel on your host system, and then it abstracts away your application with all the dependencies it needs in the jail. And at the time, it was pretty cool because you could even virtualize your network stack using something called the VNet. So I was running that stack on a very cheap Linode because I'm a very cheap person. And all of that was running initially on like a $5 Linode. And it cost me like $60 a year. I was like, this is great. It had a gig of RAM, a gig of swap space, and one CPU. And that was it. So we'll talk about that a little bit later. But I want to ask you guys, like, I'm assuming you guys are asking, like, why? Why would someone go through all the trouble of taking a perfectly functioning PHP mailer API and convert it to Rust? So the reason is I'm a Christian. I read the Bible, and this is a Bible verse. It says, therefore, whether you eat or drink, whatever you do it all for the glory of God. And for me, I try to embody that best by, even if something's not super important, if it's just a hobby, I'm like, you know what? I'm going to put my best into it. And I found that over the years, like all these hobby projects that I work on, I can then take that to a nonprofit or a small business, and I can help them solve the problems that they're having. And through like just pursuing that excellence, I decided it's more beneficial if I were to market myself instead of just being like an individual person, because it might seem more professional and people might come to me more and I get more interesting jobs. So I was like, all right, I'm going to form an LLC. So I formed ORB IT Solutions, and it has a contact page because I made a website for it. And I actually used that PHP script, so it's all linked. So then I was running that PHP script to create the form submission API. And if you want, you can also contact me on Twitter at ORB_IT Solutions or /in Orville-Bennett. Or if you want to just check out my code, which if it's here, you can freely download it and use it and do whatever you want. It's at code.orbitsolutions.dev/explore/repos. And anything in there you can use. I've got dot files, so if you're like, oh, I want to pimp out my Vim setup, I'm your guy. All right, so the problem I had is I had form data for my LLC site, and I had this PHP API that was listening for responses or requests, and then it would process that and submit it and do the thing. So it goes where? It goes to a server. And I was like, well, serverless was starting to be a thing at the time. I was like, I could do that, but really serverless is just somebody else's server. There's no such thing as serverless. So I was like, I don't want to put too much stock into that. So I had my FreeBSD server. That's what this is. I did eventually upgrade it to 2 gigs of RAM and 2 gigs of swap. And I had all these jails. So there was a web jail, which ran all the static sites. There was the PHP jail, which ran analytics. And it's been actually pretty cool to see the progression of, like, we're going to go from desktop sites to mainly mobile sites. We're going to go from Internet Explorer. Actually, no, it wasn't Internet Explorer. Yeah, it was Internet Explorer 11. It was Internet Explorer 11 to now Chrome is the dominant browser. And then I have another PHP jail, which hosts my invoicing application. And then there's a database for that. So we've got the PHP stuff talking to the database, which also talks to the mail server, because that's how notifications get sent out whenever someone's like, or whenever I'm like, all right, the job's done, I need you to pay. I'm like, click a button, it sends to the mail server sends it to you, and then you go here, you put in your info, it pays via Stripe, all nice and integrated. And then I've got the Git server, which also talks to the mail jail, and that's where code.orbitsolutions.dev lives. And then I've got Node for Ghost blogs, which is running this JavaScript on the server side. And then this is also a reverse proxy. So it's talking to all of these guys to proxy requests back and forth. And this is where my site was living, and it would send a request over to the PHP guy that would get processed. FPM, which is a PHP process, would send, it would be listening, it would process those requests, send the responses back to the user's browser, and everything was great. But I started noticing that there were some problems with that setup. Like I said, I was running on a gig of RAM, a gig of swap. And when I had my analytics server just randomly start doing these cron jobs throughout the day, it would be crunching through a lot of data, and that would use up a lot of memory. And it would also use up a lot of the one CPU core that I had available to me. So what I found was if someone at that time was going to be trying to submit a form, it would just time out, because the browser would be like, all right, I'm waiting. PHP server is like, I'm waiting too. I need to get some CPU time here. And then the browser's like, I'm not waiting anymore. We're done with this. So I could have just bought more RAM, right? Because RAM is cheap, but I'm cheap too. So I was like, no, I'm not going to do that. There has to be a better, even if it's more complicated way. So I was fine leaving the PHP process to get killed by the out-of-memory killer and just letting the analytics process just start back up. Because I feel like PHP as a language, it's born to die, right? Whenever it gets close to getting out of memory, it dies, the process spins back up. That's kind of built into the language. Not really. It's supposed to be a funny joke. But for me, Rust was the answer to the requirements that I had. I wanted something that was fast, something that was not necessarily memory safe. I didn't care too much about that, but it had a good developer experience. Because as a part of implementing my contact form, I did have to debug it on the server side using Xdebug and a bunch of other Rust tools, and I hated that. And when I don't like debugging something, I automatically just hate it and don't want anything to do with it anymore. And that was hard. So for me, the solution was Rust. That's the Rust logo. And this is Ferris. He's the unofficial Rust mascot. He's a crab, which is a crustacean, and Rust developers are colloquially known as Rustaceans. So what's Rust? It's a system programming language. It's focused on memory safety and concurrency. I don't particularly care too much about concurrency, but it's cool that that's a concern that's already built into the language that makes things easier if I were ever to go down that road. And for things that are happening on the server, that could be pretty important. So that kind of future-proofs me a bit if I decide that that is a concern I want to have. But what's memory safety and all that mean? So Rust guides the user into writing software that doesn't have the typical drawbacks that you do in other systems programming languages like C and C++. No, I really like C++, but I have been bitten by invalid memory access in the code I've written. And then you also constantly have to do your if null pointer, blah, blah, blah checks in there. And that gets annoying writing it over and over for a while. With Rust, that's not something that you need to concern yourself with so much. So you can still write code that is unsafe, but by default, it guides you into writing memory safe code. And you do that, or you can write unsafe code by opting in by using the unsafe keyword. And I was like, I love that API. It's like you're doing something that's dangerous, and it's not something weird, some weird sounding name that you have to type before. It's like unsafe. And whenever anyone sees that, they know to think, okay, I need to think a little bit closer about what's going on in this code here because it might end up biting me. And that's really how much I know about unsafe. I've never written any unsafe Rust. I never plan to. I hope I never have to. So moving on. Rust does have some drawbacks, though. For me, it was a steep learning curve. So I attribute that to the way that Rust will force you to think about memory access. So even if it doesn't call it that, there is this concept of borrowing. And the concept is central to the language. And I feel like once you start to understand borrowing, Rust becomes far more easy to approach the concept that it's trying to teach you and easy to have you learn the language, and things just seem to fall into place. That's how it was with me. There's another thing I want to point out. This has been making rounds on LinkedIn. This is a paper from 2017, actually, so it's pretty old, but it's a study of runtime, memory usage, and energy consumption of 27 languages. So this is all of them. So you can see that for energy consumption and time, Rust is in the top 3, and it's also in the top 1, 2, 3, 4, 5, 6, 7. So let's call it top 10 for memory usage. And for me, that's great because with my one CPU, I can have my Rust process the form data, do what it needs to do, send a response back to the browser, and just be done with it and be very efficient with how it handles that. This is actually a really cool paper. I highly recommend you check it out if you're interested in such things. It's a very easy read, and I think the authors do a good job of backing up the conclusions that they come to with the data that they have. So if you want some more information on that or want me to give you the link after, feel free to contact me. So one of the things that appealed to me about Rust wasn't really the energy consumption side of things, even though that is a benefit. It was the developer tooling, because it was way better than PHP's, in my opinion, but also better than other things that I was used to writing, which include JavaScript. I mean, you've got package.json, and you add your dependencies to your package.json file. Nice and easy, except when it's not and things start blowing up, right? So as a build tool, I find that Cargo is much easier to use than the build tool for other systems programming languages like Make. And there are other tools in the ecosystem like AutoMake and AutoComp, which are super duper complicated to set up. At least I find them really hard to use. But Cargo is literally a joy to use. I enjoy typing in cargo blah, 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 and some command line arguments and seeing the thing build. And then when I get errors, it's not some cryptic thing, which isn't Cargo, that's the Rust compiler, but it's not some cryptic error message like sigsev blah, blah, blah. It's, hey, you tried to borrow something and that's not going to happen. How about you try to put this ampersand on this variable and try again? I'm like, okay, I'll do that. So Clippy is another tool that's in the Rust ecosystem. It's not an officially part, but it's very helpful. And it's a great linter. So your code could be working, but it's not like rusty code, right? It's not rustic code. You can run Clippy. It will give you a whole bunch of errors. You will be sad for a moment. And then you like go through and look at what it's saying. And you're like, oh, okay, I can see it. This thing is okay, but it could be made better. So Rust Up is another part of the tool chain, and it makes installing multiple versions of Rust very, very easy. I've used Rust Up to install Rust on Windows machines, Linux machines, FreeBSD machines, Mac OS machines, and on my Mac OS machine right here, I've installed multiple versions of Rust, beta, and stable, and it's always been flawless. It's always worked just fine. And then there is the Rust Analyzer. So that makes writing code very easy because you get some extra help, like IntelliSense in your IDE of choice. And it doesn't matter if it's something like a huge, big IDE, like whatever JetBrains is selling now, or VS Code, or Vim. Like, it works in Vim. If your IDE has LSP support, Rust Analyzer will do the job. There's another built-in one called RLS, which I think is just Rust language server, but Rust Analyzer is better. Try that first. All right, so I've decided I'm going to go with Rust. Now I need to look at some web frameworks that I can use to craft this API that's going to listen for the requests. So I went to a site called Are We Web Yet? And arewewebyet.org has a list of frameworks. So I was like, all right, cool. Let's look at the frameworks. So there's a whole list, and I just looked at what's more popular, because people in the ecosystem would know better than me what to use. So there's Warp, that's got 6 million downloads. Axum has 3 million downloads. That's pretty good. I decided I'd look at those. When I was looking, Axum didn't show up on my radar. So that was actually out of the running for me. And then there are others. So there's Rocket, 2 million downloads, Iron, 1 million, and then ActixWeb, 7.8 million. So basically, call it 8 million. It'll get there. So I decided, all right, I didn't like what I saw with Iron, and it was at the bottom of the list anyway, so that was out. For Warp, I checked out the docs, and I did not appreciate what I saw. Didn't really understand how to do a whole lot of things, and it seemed like I would be taking on a lot more than I wanted to take on by using that. So I was like, all right, I'll look at ActixWeb and Rocket. And the plan was I'll just create some minimally viable things there just to get a feel of the API and the framework, see how it goes. And then whichever one I like best, it would work. So it wouldn't be like, technically this is superior to that. I was like, no, whichever one I like best, that's what I'm going to pick, because I have to write the code and I have to enjoy it. But then a weird thing happened. While doing the research, I realized that Rocket was actually the framework that's used by my password manager, Bitwarden. So there is a Rust reimplementation of Bitwarden. It was known as Bitwarden RS. Now it's changed the name to Vault Warden. I was going through the research on Rocket, and I was like, oh, this is using Rocket, or my password manager is using Rocket. That's pretty cool, and I might want to hack on that. So I decided I'm just going to pick Rocket. So Actix may have been a better choice for me, given how many other people like it, but I decided I was going to go to Rocket. Another thing that pushed it over the line for me was I went to the website, checked out the documentation for Rocket, and it is impeccable. And I like good docs. So that was a big push also to use Rocket's framework. So yeah, I've chosen a framework, I've chosen a language. I started getting into it, and there's crates, and that's what Rustations call libraries, basically. So there's a crate known as CERDI, and it was popping up a whole lot throughout the Rocket documentation. I was like, all right, I should probably figure out what this thing is doing. And it handled serialization and deserialization, hence the SIR and the D. So I decided I should probably finally figure out what serialization and deserialization are. So if anyone doesn't know, serialization is you take a bunch of data and you strip it down into a series of bytes, and then you can store it or you can transmit it. And you do that because whenever you reconstitute the data, basically, you have exactly what you had before. And that process is deserialization. So you're reconstructing data from a series of bytes, and then your original information can be used. So for my purposes, whenever I've got my form on a web page, it's all strings, and the browser will take that data, convert it into some bytes, send it off over the network, and then that is serialization. And then it's going to get deserialized by my server-side application, whatever that is, PHP server, Rust, Go, doesn't matter. And then it's going to be stored in a form that the application understands after deserializing it. So I didn't understand any of this before. I was gleefully using that PHP API without understanding some pretty important stuff. And that's fine. I think there's a time and place for that. But at this point, I was like, no, I want to go really into it and understand what the application is doing. And I appreciate the fact that Rust helped me, or maybe I should say forced me, because I saw like CERDI popping up all over the APIs to learn what this did. And I appreciate tools and languages that help me to learn. And if I learn more during the implementation than I did before, that's a win for me. So I was already coming out ahead, even though I hadn't written any code yet. So now I'm going to get into the how. How did I do it? So this is the original code for my PHP mailer API. You can see we've got an email that's going to be set for receiving and sending. And then we've got these fields. So PHP has its post super global, and it stores stuff that gets sent to it. And full name, email, message, and subject are the fields that are created on the browser side. And then we start setting up headers here before we do more stuff. So this really is the important bit. 4 lines is what I was dealing with in my PHP script. And then I wanted to optionally just not have the subject. And this is the 5-minute PHP job. Basically, you throw that in an if statement, and then if your check is coming back without any data, you assign a string to it, and then that's your default subject, and then you're done. And then you take 30 minutes to debug it on the server and figure out why it's not working. And that was a part that I was like, I don't want to go through that. There's got to be a better way. And this is the rest of the script. So this is setting up the actual email, and then you send it off using the mail API. And so my first stint at debugging the PHP mail script was, this used to work. And then I migrated to a new FreeBSD jail, new version of operating system, probably a new version of PHP. I didn't pay attention. I should have, but I didn't. So then it wouldn't work. And I was like, why isn't it working? So that's because whatever I was sending before, the order wasn't correct. So now I had to send this order and also encode the message. And debugging that was not fun. And I decided I didn't want to do that again. And that is just the rest of the script, which, so at the top, we had our check input, and if there's any problem with any of the input here, if it doesn't validate, it will then go through and run the show error form, or the show error function, and then it'll spit out a message, send that back to the browser, and exit. But if it doesn't do that, then it goes through, it sends the email here, and then it says, thank you, we'll get in touch with you eventually, and then it exits. Very simple code. All fits within 60 lines. That's beautiful, right? It's concise. I think it's understandable. Gorgeous. Except for when it just doesn't work. All right, so let's go to Rust. So I'm starting the Rust project. I'm like, all right, cargo new formulate, because I like to come up with cool names. I was like, I'm going to call it formulate because it's dealing with forms and blah, blah, blah. So kind of like a package.json, you've got your name, you've got your version, but also there's an addition here, and that tells you which version of the Rust ecosystem you're going to target for your code. And then you list out your dependencies. Rocket, of course, because that's the framework I'm going to be using. And then features which aren't baked in by default. So JSON, the JSON feature gets you the SERDI package included in Rocket with all of those capabilities. And then letter, I was using to use it to send the emails, the letter crate. And then I was like, let me do some validation. So I added validator. It seemed pretty light and easy to use. And then there's also these profiles that you can have. So debug profiles, release profiles, whatever other profiles you create on your own. And you can have the build do stuff based on what you've set in the profile. So as of Rust 1.59, you were able to strip debug info from your release binaries, which makes them smaller. I'm like, all right, that's cool. Let's do that. So I threw that in there as well. So next, let's talk about some developer plugins that help you to be your best Rust dev. So Rust Analyzer, I talked about before. There's a VS Code plugin for that. There's a Vim plugin for that. Both work great. You can be in the console and command line. You can have a little drop down once you start typing your variables. And it can have, once you highlight each of them, it can have documentation, which you've included in your code. So that's a cool tool I like. Then there's Code LLDB. And this is a debugger. So just like you can debug your JavaScript by setting a breakpoint, your code will break there. You can inspect all the variables, see what the values are. You can do the same thing with this plugin. So both of these, I think, are really cool tools. And then, of course, there is RustUp, which installs the Rust toolchain itself. And it works on all these Unix-like operating systems and Windows subsystem for Linux. Before I actually jump into the code, I'm going to point out something that I found weird. So if you start writing code, you're going to see that there is actually a difference between a string slice and a string. So a string is something where you don't really know the size. It's allocated on the heap because you don't know the size. And then you have a string, which is a specific size, and the compiler can determine that and pretty much bake it into your code. So it's static. And that's not a string. It's an str. And you're taking a reference to the str, actually. And that was weird for the longest time until I got what that means. So basically, you're saying here, you're borrowing and getting a reference to where it lives in memory. And then once I got that, see, the whole borrowing thing starts making sense. I was like, oh, okay, all right, that makes sense. And there's also something missing here, which I didn't add. And I think it's really cool that I didn't need to add that. So I said it was static, which means it's baked into the thing. There is a concept also of lifetimes, which I won't get into very deeply in Rust. And static is a lifetime, which means it's available forever. And I don't need to put that here because the compiler can actually infer that. And that is one of the other nice things about Rust. So if the compiler can infer a type for you, you do not need to type it in. And if it can't infer the type for you, it will let you know, and then you'll do it. So yeah, so you can change the and str to and single apostrophe static str here. The code will still compile, do the same thing. All right, so here we have my form API. I want to make the subject line optional. And here is the beginning of how you do that in Rust. So there's a couple of things to explain here. On line 37, there is a derive macro. So whenever you have lines that start with a pound and square brackets, those are macros. And that is a way Rust provides to allow you to extend language without it being official. So create authors can do that. But derive is actually built into the Rust language, and it allows the compiler to provide basic implementations of some traits. The things within the parentheses here, those are the traits. So debug, deserialize, and validate. And it's seeing stuff like that that made me want to figure out what exactly deserialize is. So deserialize is a trait that is provided by SERDI, and that allows this struct, which SERDI is operating on, to do things like provide aliases, do some validation. Then there's also actually I think this validate trait is what allows the validation to happen here. And these also kind of like the macros. So I don't understand a whole lot how to do them or how they work rather, but it's pretty cool that if I wanted to implement a the ability to have stuff about my struct here, form submission JSON, printed out, I would not have to write the debug implementation myself. The compiler is like, all right, I can give you a basic implementation of that, which will provide you with the form, with the struct name, and all the fields in it. I'm like, well, that's all I really care about. So that's great. Do the work for me, please. And then same for deserialize. I didn't have to write a function implementing the deserialize trait because it could just automatically be derived. And that is one of the nice things about Rust. It can get very verbose doing certain things, but they've thought about that and was like, all right, we're going to provide you with the capability and to make it easier. And also authors or library crate authors have latched onto that and have hooked into that functionality as well. Some people hate macros because like it's magic and you don't know what's happening behind the scenes. But I love magic as long as it works. And for me, this works great. So yeah, we've got a struct here, and these are structs just like in other languages, Swift, C, C++. There is no concept of class in Rust. There's also not inheritance. So how you extend something is by implementing those traits. So here we've got the struct and we've got fields. And unlike in PHP, I have to say what the type is for these fields. But I can also additionally give aliases to these fields. So now when I get a form submission and a field is not full underscore name, but it's full uppercase N name, it'll work. And I can do the same thing with all lowercase full name. And that is a little nicety that I appreciate because I would have had to duplicate this multiple times in order to get the same thing to work in PHP. And for the if-else statement that I would have had to add for my optional subject, well, here Serde allows me to just pass in this is actually a function, which is defined above, pass in the name of a function, and when that function runs, it's going to return a string, and then that string will set the default subject if one is not provided when the form gets submitted. And Rocket, as a framework, takes care of all of that behind the scenes, which I love. And also, I did some validation initially here, and then I was like, nah, I'm not going to bother validating. But I could, if I wanted to, do a bunch of validations using that validator dependency that I showed you guys. So here I was going to try to make sure that your message is at least 4 characters long. So if you're like, hey, and then you submitted the form, it's like, no. But then I was like, you know what? It's fine. What's the difference between hey and hey with a period? It's not a big deal. So then we've got some more aliases here. And this is basically laziness. And I love when languages enable me to be lazy as a developer, because I just call that efficiency. So I have existing code, right? And these are the fields that tell me what location the form's coming from. So I can just throw in some aliases here, like site, website, location, and also from site. And that is, I think, a lot of magic that is happening. But as long as the magic works and I don't need to worry about it, I'm okay with that. And I think it's really cool that the compiler is able to generate these basic implementations. And maybe it'll be extended even more. I don't know. But I think move over Copilot. We've got Rust C here. All right, so now let's talk about getting results. And I think I am actually going to drop out of the presentation here and instead go to VS Code, because this is, I'll do it here. All right, so getting results. So this weird thing, that's not an accident. That is actually a Rust type that you can return. And your Rust type of result is a combination of OK type and an error type. So you must return one of these, or else bad things will happen and the compiler will shout at you. But it's
like a maybe. Have you heard of a maybe in other languages?
No.
Okay.
So there is also an option And result is basically like a superpowered option type. So option is, it represents an optional value, and you can either have sum and then whatever your value is, wrapping, the sum will wrap whatever that value is, or you can have none. And if you have that none, well, then you don't have any of that thing. So the option types are very common in Rust code, and they have a number of uses. So this matching, that's basically how you get a value out of something that is optional, or a result type, which is the type of an option. And both of them are generics, so you'll have to pass in the specific types that you're expecting back here. And for me, whenever you hit the submit function, which I'll explain how we even get that far later, it's going to return a result, and that is going to be a tuple, and the tuple has a status type and a static str. So this static str is actually this guy, which was in the first set of string slices that I showed you. And here, I needed to define it as static because the compiler wanted me to. And you're like, why couldn't it infer that? I mean, it knows what the type of this is. And there is, I'm sure, a very good reason why it does this. But I do not know what it is. So there we've got our OK type here. So this value, whenever you return it, it has to be wrapped basically into that OK. And then we've got our error type, which is bad request. It's also a generic. So the specific type is going to be string. That has to be wrapped in error, which then has your sum, which is coming from this guy, which is also maybe not maybe anything. It is a value, but you need to pass it into the sum type because that is what bad request expects. And that kind of tripped me up a bit as I was going through this. I was like, all right, I'm passing my error, which is a string, into bad request. Why isn't it working? That's because you screwed something up, and I didn't read the API properly, and I was missing the sum. So let's go back all the way to the top and explain what's going on here. So we've got this little macro, which is saying that whenever you have a post request for the index route, I want the data that's coming in to be stored in the form variable. And then you're like, all right, so that's what submit's going to operate on. You need to say what the type of that is also. So the type is going to be form, but specifically form submission, which I didn't show you. I showed you guys form submission JSON. So once you have that all set up properly, because it's of this type, then it has certain capabilities because of traits. And one of those capabilities is validate. That's provided by Rocket. So once the validate function runs, I get back a result. And it's either got some errors or it's got what's known as a unit type. So when you have exactly one value and there isn't anything else meaningful that you can put in it, that's just your unit type. So here, once this returns, it's going to return the unit type. Here, it's going to return our error type. And we can check whether this is an error or not, because Rust knows, because it knows all of that info. And there's this syntax here that's like, if validate is an error, you can assign that to the error thing right here. You can assign an error variable here. And then within the curly braces, you can do stuff with it. And you'll notice a lot of these lines, when they end, have the semicolon. This one does not, and that is because Rust allows you to just return whenever you want by not having the semicolon at the end of a line. So you don't need to type return whatever the value is specifically, and then a semicolon to end that statement. You're just like, no return, get rid of the semicolon. And at first I was like, ew, why wouldn't I just say return? And then I started loving it. Because it's really handy. So this will return at this point, and that's the end of the program right there. It sends an error back to the server. Or you're all good, there is no error, so it falls into the else statement because there is no error. And then I basically take the form, and I take the and SDR versions of those. So I'm basically borrowing, and I'm not passing ownership into send email. Because if I did that, it would transfer ownership of those. And if I tried to use them outside here, then the compiler would give me an error saying, no, 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 can't do that. So I'm not going to really go into send email and what it does. It's the same type of thing where there's a bunch of matching to get values out, and there's a bunch of validation that looks very similar to this. So that's not very, very interesting. But here, after we get our results, then it is either the unit type or it is an error. And if it is an error, then we're going to try to figure out what type of error it is. So mail config error is an enum. And there are a bunch of enumerations that I listed, 4 of them, exactly 4. And unlike other languages where you can just like put a default at the end and just put something that is pretty generic, Rust is like, no, you have to tell me what every single one of these are. So if you're to put 50 of these in an enum block, you would have to define the result for 50 of these. Maybe that'll change in the future as the language matures, maybe not, but I didn't have much of a problem with it. But what you see here is you're matching on the variable error, and then you're saying, all right, is it of this type? If so, this is what I'm going to do. I'm going to wrap my bad request string into the error type and then return. There is no semicolon at the end of any of these, so it's just returning right here. Same for this. So it's basically whatever app config error string there is, it's going to return that as bad request, send it on to the server. If the type is a unit where send email didn't return an actual value, then it's like, all right, we're good. And I, at that point, decide if there is no error, this is what I'm going to send for the status, which is OK. And then my success message, which is baked into the binary. And that takes care of pretty much the bulk of the submission API. I've got one of these for JSON and one for non-JSON functions. So this is the JSON version of the same thing. And I have a questions thing here, but we're not going to go into questions just yet because there's more. So I told you that I hate debugging PHP, and I do. I really do. One of the things that's nice about Rust is you can write, it's got like unit testing built in as something that they've considered how to do. So at the bottom of my main.rs, let's scroll on down. Uh-oh. VS Code does not like what I just did. So anyways, I'll keep talking until this happens. So somewhere down here, there is a, yeah, right here. There is a line that says include test dot blah, blah, blah. Come on, come on, come on. There we go. So with this macro, which is called config, I'm passing in that it's a test. Rust now knows whenever I am in cargo and I'm like, cargo, command line, some option, tests, it's going to run all the tests that it finds in this file. So let's go here and actually check out one of these tests. So here, Rocket's got the concept built in of like an integration test. So I can fire up a Rocket server, set some things up, and then basically pass some values into it to simulate someone submitting a contact form, and then assert that certain things are supposed to happen. And this was actually handy in helping me find a bug that I had in my application because I made a change, right? And then I didn't go through and make sure that every change that I should have made was made. And my unit test was failing. And I was like, what is this stupid test failing? That doesn't make any sense. And then I dug into it and I was like, oh, I forgot to update something over here. So then the type that I was expecting to get back was no longer correct because I think I changed one of my error enums. So that was pretty cool. And I dread thinking how that would have manifested if I was trying to debug it in PHP land. So the other neat thing is, since this is VS Code, you can just click on run tests and it'll run the test in line, give you a bunch of output here, and it's all nicely integrated. Looks like I have an error. Don't pay any attention to that. I was making changes today. And then the next thing I did was I decided, all right, I've got my unit test. This is a great thing to start doing some DevOps work on automate it. So that's what I did. So I set up a GitHub action that would do a build on Ubuntu. And I didn't really do this on FreeBSD, which I guess I could have done. But I was like, when we're in this VM or whatever it is, container, I want to check the stable version of Rust, the beta version of Rust, and Rust 1.59. So I do that because that's the minimum supported Rust version of the Formulate application. And then it goes through, it checks stuff out, and then this actions toolchain makes sure that I have Rust format and Clippy available, because no matter how vigilant I am never ever going to run Clippy after every single commit when I'm actually deep in the bowels of development. So it provides those tools for me, and then as a part of a lint check, which is down here, it'll run a format on them, see if there's anything weird, and then it runs cargo Clippy. And you can set that to just be a warning, and your GitHub Actions will pass if there are errors printed out, or you can set it to an error. And in bigger teams, of course, that's very helpful. And then there was like one thing I could not figure out here in my action, because it would run, the tests would not pass. And it didn't make any sense, because I've tried this on FreeBSD, it worked just fine. I tried it on the Mac, it worked just fine. And I was like, all right, I'm desperate. It's Ubuntu. Let me try it on Linux, see what happens. And it also worked fine on my Linux machine. It would not work in the GitHub container. I was like, this does not make any sense whatsoever. I was like, all I'm doing is passing something off to SendMail. SendMail is doing its thing, and then it's returning either yes, which is a 0, it worked, or some other number that's not 0 because it failed. I was like, that doesn't make any sense. Why it's not working? Until I figured out GitHub, or the GitHub container I was using, doesn't actually have SendMail. And I'm like, I don't have root on there, so I can't install anything. I probably could if I did look into it. I was like, all I really care about is when I pass the data to something that is executable, named SendMail, does it succeed or does it fail? So I was like, all right, I'm going to create a script. And what the script does is it will put in the workspace a script file named SendMail. I'll make it executable, and then I make sure it executes, or when it exits, it's a 0, which means, yay, everything works. So the cool part about this is now I don't actually need the SendMail binary, and I can go through the SendMail documentation and be like, all right, what are all the statuses SendMail is going to return? Let me -1 for you screwed up on one of the return addresses. I can put that in there and have different scripts run for different scenarios and basically continue running my test properly without having the actual binary. I was like, oh, that's actually pretty cool. And then, of course, we have the actual build file, and it goes through, and I make it verbose, because whenever things do go wrong, I don't want to have to go back in and see, well, what was the error? And GitHub's paying for all the extra output anyway, so it's fine. So this is how I set up the automation for testing the Formulate binary, and it was all nice and easy, and that's pretty much all I have to say about that. The Rust toolchain enabled a lot of things that would never have happened if I had to set this up manually for PHP, like on my Mac, install multiple versions of PHP. I've done that before using Homebrew. It's no fun switching back and forth. So this really, it incentivizes a developer to do the right thing, which I like. And that is my talk about Rust. So for me, I feel like it was worth going through all the hassle of a year of figuring out, what's the borrow checker doing? Why do I care? Okay, this is why I care. Now I can start actually doing things with it. Even though it was a long and arduous process, it was totally worth it, because now when I'm working in JavaScript land, which is like the Wild West of types, I can be like, well, maybe I should pull TypeScript into this project because there are benefits to that. So are there any questions?
Knowing what you know now, would you make the same choice?
Knowing what I know now, yes, I would make the same choice. I have no regrets about doing this. And if someone else were to be like, oh, I've got this PHP project, do you think I should convert it into Rust? I'd be like, well, what are you actually trying to do? How much work is it going to take for you to re-implement all of that? And are you willing to basically deal with the frustration? And if the answer to all 3 of these things are yes, then I'm like, go ahead. If you're like, I don't want to put that much work into it, I'd be like, no, it's not for you. Not because it's bad, just because we all have a finite amount of time, right? We've got families, yada, yada, yada. So if you're willing to, I don't know, put a year or 2 into converting a bigger project, sure, go ahead. If you just want to throw in the if statement and be done with it, no.
or I guess I should say, would you recommend somebody else do that?
So if I were doing it, yeah, I would, because it would help me to understand more of the language. And I also now enjoy writing Rust code, and I enjoy the tooling. So any frustration that I anticipate, I think would be worth the pain. If someone else were doing it, then I'd be like, all right, so what's your time commitment for this project going to be like?
Yeah, I guess another question would be, what is the case for Rust outside of the application? It's like, super hard real time.
So keep in mind my requirements. I am cheap, and I do not want to upgrade my Linode, and I want to get the best performance I can from the weakest system I can possibly afford. And it fit my use case perfectly. And if you're in a similarly constrained environment, I'd say go ahead, go all in on Rust. And if you're not in a constrained environment and you're just like, I want the best performance possible, yeah, go with Rust. Like, you can get pretty good performance out of JavaScript, but it is never going to approach the performance that you can get out of something in Rust.
Do you still have stuff running in PHP?
Yeah, I do. I still got my API for the analytics server. Not API. I still got the analytics web application that's running in the PHP jail. I've got my invoicing application, and I have been playing with my mind. I was like, should I just re-implement these APIs in Rust? Because now I know how to use Rocket. I don't think my wife would like that very much, though. Thanks for all the questions, guys. It was fun getting to geek out about Rust, and hopefully I've given you some useful info.
Thank you, Orville. That was awesome.